After World War II, several nations across the globe were ready to modernize their armies and embrace a new generation of warfare technology, and the Royal Swedish Army was no exception. In the mid-1950s, the Swedish prepared to replace their highly successful Centurion tanks with a new tank that would be like nothing the world had seen before. Their plan was to build the first tank in history to use a turbine engine instead of a conventional piston diesel engine, ensuring that the vehicle's power and speeds were superior to most existing tanks. The tank would also be fitted with a mighty Bofors 105mm L74 rifled gun that would provide it with immense firepower on top of its unparalleled agility. Still, the engineers' research showed that the tank's height was closely related to how vulnerable the vehicle was, and the Royal Swedish Army Material Administration made a decision that would define a new generation of armored warfare. In both World War I and World War II, the Swedish did everything in their power to remain neutral, but they eventually leaned to the side of the Allies, providing humanitarian aid and other supplies while making it clear that they did not desire to participate in the conflict. Their neutral philosophy resulted in a military perspective focused on defense rather than offense, and in keeping their soldiers' lives safe at all costs. While other nations were developing armored vehicles, prioritizing the highest scores possible, the Swedish focused on a robust and agile tank that would be hard to hit and with no apparent vulnerabilities to be exploited. Hence, after carefully studying tank casualty rates from World War II and the Korean War, Swedish engineers realized that most of the damage caused to a tank and its crew happened when the turret was struck. The turret was a significant vulnerability point because it was the highest point in the vehicle, making it easier to be seen and targeted above terrain bulges and other obstructions. However, another disadvantage was that turrets were designed to rotate freely to aim the main gun, which meant that the connection point between the tank and the turret would always be a weak spot. If a lucky hit impacted the connection point, it would be much more likely to inflict fatal damage to the crew than if it struck a more heavily armored tank section. The decision was then taken to build a tank with no turret. Getting rid of the concept of a rotating turret brought many advantages to the eventual Stridsvagn 103, or STRV 103. It made the tank height much lower, significantly decreasing its chances to be hit, and it also made the tank considerably lighter, resulting in a faster and more maneuverable vehicle. If that wasn't enough, foregoing the turret also allowed the STRV 103 to be completely amphibious while lowering the risk of flooding. The final design ended up with a height of exactly 7 feet, which was a significant improvement over other tanks of its type that reached over 9 feet, making them a somewhat more visible target to anti-tank crews and their weapons. Having no turret system also left much more space for the crew inside the vehicle, which translated into an additional groundbreaking feature: the addition of duplicate controls for crew members. While other tanks needed a crew of 4 to operate correctly, every position inside the STRV 103 had a set of duplicate controls that allowed each serviceman to perform the functions of other crew members from their very own post. In theory, this meant that a single crew member could operate all the tank's tasks from a single spot. Despite the novel feature, Swedish authorities decided that operating all tank functions was too much for one crew member or even for 2, so they agreed that the minimum operational personnel would be 3 servicemen. Still, the duplicate control function gave the tank a significant advantage. In the case of an emergency, any crew member could take over the functions of another operator, making the functionality of the tank much more efficient and practical. Even though the decision to exclude a turret brought many advantages to the design, it also entailed severe complications, the most significant of which was aiming the gun. As the STRV 103 had no moving turret, the main Bofors L74 105mm L62 rifled gun was mounted directly into the vehicle's hull, which prevented it from rotating or tilting up or down independently from the tank. To solve this disadvantage, the STRV 103 was fitted with a fully automated transmission and suspension system, which accurately turned and tilted the tank under the gunner's control. In short, the whole tank would rotate and elevate or lower its hull to point the gun in the right direction. The fixed gun configuration came with a considerable price, as the tank could not accurately move and fire simultaneously. Still, the Swedish didn't fret about that drawback, as experience with Centurions had taught them that most tanks tended to stop before they fired. The end result was a sight to behold. When the tank attempted to acquire a target, it would swiftly rotate to face the direction of the opponent, and just as a modified lowrider car, the suspension system would elevate or descend the front part of the tank in order to tilt the gun in the adequate angle. The suspension and transmission systems were remarkable, and they gave the tank unparalleled maneuverability and speed. However, such features would not have been so impressive if it wasn't for the tank's state-of-the-art engine systems. Besides having no turret, the other factor that made the STRV-103 utterly unique was the fact that it was the first tank to be propelled by a turbine engine. When most armored vehicles still used piston diesel engines, the Swedish decided to push technology further and equip their already ambitious tank design with a powerful 490 horsepower Caterpillar turbine. The potent aircraft turbine engine was designed to operate as the tank reached high speeds to give it additional acceleration and agility. In contrast, a 240 horsepower Rolls-Royce K60 opposed piston diesel engine would produce the propelling at lower rates. The dual-engine configuration was the first of its kind, and it was possible thanks to the additional space available inside the tank, resulting from the relinquishing of a turret system. The final product was a fast, limber, low-profile tank with outstanding armor but awkward aiming functions. Still, during early testing, the STRV-103 was found to be reliable and safe, and it was deemed an essential asset for the Royal Swedish Army. Additional trials were conducted in 1967 when Norway carried out a 2-week comparative observation test with the Leopard 1 and concluded that the STRV-103 acquired more targets and fired faster than the Leopard. Furthermore, from April to September of 1968, 2 STRV-103s were tested at the British Armour School in Bovington, after which officials reported that, quote, "The turretless concept of the S-tank holds a considerable advantage over turreted tanks." Unfortunately, a sudden change in military direction in Sweden during the 1980s turned the defensive tank doctrine into an offensive philosophy, while budget reductions also called for a diminishing of armored forces. This resulted in all Stridsvagn 103s being decommissioned and replaced by the newer Stridsvagn 2000. Ultimately, the Stridsvagn 103 never saw active combat, despite the promising test results. The formidable Swedish CV-90120 light tank has recently received an astonishing upgrade that almost seems to push the armored vehicle into the realms of science fiction. Already possessing some of the most impressive mobility to firepower ratios in the armored combat vehicle industry, the CV-90120 is now undergoing the addition of the Ghost Adaptive Infrared Camouflage System, which is sure to make the light tank a remarkable asset in the arsenal of future warfare. Because the most effective anti-tank guidance systems, like the ones used by the US Javelin, rely on infrared detection, having an armored vehicle that can effectively mask its infrared trace and even disguise it to fade into the environment is a significant achievement. If the project continues as planned, the CV-90120T will be able to deliver devastating firepower while remaining technically invisible to the enemy. A proper ghost tank. The new CV-90120T is built from the hull of the highly renowned and reliable CV-90 infantry fighting vehicle. This family of tanks has built a pristine reputation since its inception in the late 1990s for its excellent mobility, speed, and superb firepower capabilities. The original CV-90120 was developed to provide Swedish military forces with an option to mount a light vehicle with the firepower of a main battle tank, comparable to the Leopard 2. The need for such a tank stems from geography itself. Northern Sweden has very few roads and extremely rough terrain, both during summer and winter months, and such a factor needed to be taken into consideration for the CV-90120 to prove effective for the Nordic country. The CV-90 had already accomplished remarkable agility and speed, but it lacked the firepower to neutralize the heavier armored vehicles developed by Russia and other military powers across the globe. Thus, When designing the CV-90120 BAE systems, the engineers were tasked with building a solution that successfully combined the ultimate mobility with maximum firepower. However, its development came at the cost of relatively light armor protection. The initial prototype of the CV-90120 was fitted with a novel welded turret to accommodate a greater caliber tank gun. Outside, the chassis was entirely identical to a normal CV-90, preserving the same engine, suspension, and internal structure. Still, the new iteration was adjusted to support the increased weight of a more prominent turret and a larger caliber gun. The prototype vehicle ended up weighing around 20 tons. To provide the required heavy firepower, the CV-90120 was fitted with CTG 120mm smoothbore, a lightweight, potent gun developed by RUAG Land Systems. This cannon was light enough not to deter from the vehicle's mobility and had low enough recoil force to avoid damaging the tank as it fired. Additionally, the gun was designed to accommodate all current and future NATO 120mm ammunition, which was deemed sufficient to face most threats in the near future. The weapon also showcased a formidable range, giving the CV-90120 the ability to engage most other armored vehicles while staying well outside the scope of their guns. To go even further, the new tank also featured a bustle-mounted semi-automatic loader, granting the light tank a fire rate between 12 and 14 rounds per minute in the hands of an experienced crew. Also, the ammunition was safeguarded within a protective case separated from the team to prevent them from so-called ammunition cook-offs. The unique weapon system came with an equally remarkable Saab UTAAS computerized Universal Sight and Fire control system, which provided the gunner with a reliable way of hitting targets in day and night scenarios. The CV-90120 would eventually become a significant success for the Swedish military, a highly valued armored solution that responded well to the terrain necessities of the North. Still, it had a significant drawback in its light armor, and to address it, BAE would eventually develop more complex versions. One of these was the Ghost tank. Having limited protection is not such a big issue if you're invisible to the enemy. That's the reasoning behind the recent CV-90120T Ghost prototype, taking all the advantages of the CV-90120 platform while drastically diminishing its inherent disadvantages by implementing a state-of-the-art Ghost adaptive infrared camouflage system. The adaptive stealth system was developed and patented in Sweden after FMV. The Swedish Defense Materiel Administration commissioned BAE Systems to research and develop full-fledged technology for combat vehicles to avoid detection from thermal sensor arrays. Then, after 3 years of demanding research and prototyping phases, a unique team of problem solvers, software engineers, sensors experts, electronics engineers, and weapons designers created this unprecedented solution. The high-tank camouflage array uses modules that look like cells configured in a honeycomb structure to cover the flanks of a tank. The modules are specially constructed so that they can be individually cooled or heated remotely and at very high speeds. Endowed with such a versatile camouflage system, an armored vehicle can simultaneously activate all the adaptive modules to completely disappear from thermal sensor systems, or activate only some modules in a specific pattern to blend into a particular environment or mimic the characteristic of some other vehicle. The CV-90120T Ghost essentially works like a chameleon, able to simulate its surroundings or reproduce the appearance of other objects such as trucks and cars that can be projected onto the modules from a detailed image database. But stealth is not the only function the camouflage panels can provide. They can also signal peaceful intent through flashing text messages across the tank's flank, or by creating patterns that can easily be recognized by friendly parties. This makes the Ghost a formidable opponent and an excellent tool for de-escalation when the operation demands it. The stealth adjustment implemented in the Ghost tank goes beyond the adaptive system. However, its outer facade has also been modified to reduce its signature against radar detection. Like the iconic F-117 stealth aircraft, flat sweeping surfaces have been placed over the gunner's sight and the 120mm main gun and mantle in a unique configuration that aims to reduce 90-degree angles, easily distinguishable in radar sensors. To further compensate for the light armor mounted on the Ghost, the tank is also fitted with groundbreaking active protection. This dynamic protection system is designed to prevent the impact of inbound projectiles on the tank's hull as a last resort defense if all preceding systems have failed to protect the vehicle. The production array was developed by Akers Stickbrook and works by firing a sensor-activated high-explosive charge towards projectiles to intercept large-caliber ammunition rounds directed at the vehicle. Even if the stealth systems are circumvented, the Ghost still has an ace up its sleeve to avoid being hit by enemy fire, making it a highly resilient combat vehicle. The result is a limber and highly maneuverable tank, capable of going over 40 miles per hour with a powerful 120mm gun that can easily outrange most other armored vehicles of its kind. Furthermore, if the tank is already within the range of an enemy vehicle or anti-tank crew, the opponents will have a powerful tank picking up the Ghost in any infrared detection system thanks to its adaptive infrared camouflage system. As armies worldwide develop unique new weapon systems to meet the warfare challenges of the future, the CV-90120T Ghost is paving the road for a new generation of armored combat vehicles capable of engaging the enemy in unprecedented novel ways while remaining virtually undetected. In short, the CV-90120T Ghost is a glass cannon, but an invisible one. With Russia becoming a highly dangerous threat once again, the Scandinavian nations have been forced to take a look into their military blind spots. As Sweden considers joining NATO, its military has scaled up its training on the remarkable Stridsvagn 122, recruiting new conscripted troops to handle the enviable armored vehicles. Born from the legendary German Leopard 2, the Swedish tank stemmed from the legacy of World War II and the knowledge gained in the Cold War. But when it entered service in the 1990s, the world had found a renewed peace, however brief. In 2005, the Swedish military withdrew its forces from a crucial perch in the Baltic Center, the island of Gotland. Sweden has been waiting a long time to return to the windswept island. But as unit commander Carl Engelbrektsson put it, quote, "Disbanding large parts of the armed forces in the peace euphoria of that time may have made sense to a lot of people. History proves that this was a mistake." Following the Cold War, the Swedish government needed a main battle tank to replace its obsolete vehicles. As such, they undertook a program to upgrade their armed forces, including replacing the aging World War II-era STRB-102-102 and STRB-103. In the STRB-NY initiative, 3 foreign tank types were selected to participate in trials to become the basis for the new development. They were the American M1A2 Abrams, the German Leopard 2A5, or Improved S, and a prototype of the French Leclerc, then in development. The military conducted strenuous trials, but the Leopard 2 eventually emerged as the winner. The model fulfilled the Swedish military's battlefield requirements and capabilities more thoroughly than any other, and the Leclerc fell short, partly because it was not yet mature enough for service. In 1994, the Swedish government acquired 120 new production tanks and 160 older Leopard 2A4s that would double as a stopgap before the more recent versions were ready. The entire deal cost the Swedish government $770 million. The Leopard 2A4 was thereafter designated Stridsvagn, or STRB-121, while the new tank, the Leopard 2A5, would become the STRB-122. After entering frontline service in 1979, the Leopard 2 branched into a plethora of remarkable variants and specialized battlefield vehicles, all stemming from the same chassis. The Leopard 2A5 was a notable addition to the family production line. It was the first variant to showcase the revised, well-sloped frontal turret facings that housed so-called spaced armor, intended to counter hollow-charged projectiles. In addition, the overall weight of the vehicle was lightened by using a new fully powered turret with electrical control. In 1998, the German Army was the first to receive the revised variant, and later opened its procurement to other nations. The Swedish STRB-122 retained much of the appearance and capabilities of the German original, such as the twin-turbo MTU MB-873 KA501 12-cylinder liquid-cooled diesel engine with 1,500 horsepower. Plus, The Swedish version had a 120mm smoothbore L55 main gun, torsion bar suspension system, low-profile design, and 7 double-tired road wheels. In fact, the vehicle received its name from its 12cm gun. The STRV-122, also known as Leopard 2S, is often described as a Leopard 2A5, but it is notably the most heavily armored of the kind, closely resembling the Leopard 2A6 EX tank when it comes to protection. Curiously, it is also the only Leopard 2 variant fitted with the French Gallic smoke grenade launcher system. The system comprises 2 banks of 8 dispensers added to each side of the turret. Developed by Nexter, it was fitted on all STRV-122s to be able to fire many grenades, to either mask against IR detection or launch decoys or anti-personnel grenades against infantry. The STRV-122 kept many features from its predecessor, like its width of 3.75 meters, although its weight was slightly increased by 350 kilograms. Notably, the new variant was designed to endure Swedish conditions, from urban terrain to heavily forested areas. The STRV-122 also had a wading capability that allowed it to pass through water up to 1.4 meters deep. The Swedish version was also required to overcome the original German tank's shortcomings. Therefore, it was equipped with an advanced CBRN defense system that offered protection against chemical, biological, and radioactive weapons. With the assistance of a laser rangefinder, thermographic camera, and speed distance accuracy calculator, it had the ability to quickly discover, identify, and lock on to a given target. Moreover, it could lock onto numerous targets at once, engaging many enemy vehicles without needing to stop and manually re-aim after every shot. On the other hand, the tanks were fitted with active communication that improved cooperation between units. Other major differences included an upgraded fire control system that enabled enhanced accuracy while firing on the move, and an increased 3-ton frontal armor that provided better point ballistics defense. With it, the turret roof armor was also better protected. The vehicle was also fitted with Swedish radio equipment, a Raman-shifted NDYAG laser rangefinder, and a modular tank command and control system, or TCCS. Its complement consisted of a crew of 4, namely a driver, tank commander, gunner, and loader. The first batch of 29 tanks was built in Germany by Krauss Maffei Wegmann, and the remaining 91 were manufactured locally by Bofors Defense and Albus Hägglunds. They were first delivered to the Swedish Army in 1996, and several variants have emerged since then, like the STRV-122B or 122B+. For one, the STRV-122B sported a modular armor that allowed a smoother deployment in Afghanistan and Iraq. The new threats from the Taliban forces and insurgents included a large-scale exposure to improvised explosive devices and the infamous Soviet-era rocket-propelled grenades, or RPGs. Later, the STRV-122B+ evolution, with increased protection levels and advanced composite materials, was proposed. As of 2013, there were 42 original tanks still in active service, while most of the leased Leopard 2s were gradually returned to Germany. The tanks still in operation were divided into 3 companies, 2 at P4 Skövde and 1 at I-19 Boden. A few years later, the government established another company at the P-18 Regiment on the island of Gotland, though the trained units didn't arrive until 2019. A new set of upgrades is expected to be delivered by 2023 at the latest, including a new observation and gun site for the commander, communication systems for international missions, and a modular 360-degree ballistic projection system. The new vehicle will receive the designation STRV-122C if implemented on a 122A, or STRV-122D if the upgrade is applied to a 122B. Late in 2021, the Swedish began implementing their own training activities, just as the Russians increased their military buildup on the Ukrainian border. The Swedish armored maneuver battalions hadn't trained on the STRV-122 in years. Besides, the Swedish Army got a $27 million deal for Israeli M339 tank projectiles, representing a huge step up for the platform. In truth, Gotland provides the Swedish military with an advantageous position in the Baltic, as they can control critical naval routes and airspace from the island. While the bastion seemed irrelevant a few years ago, Sweden is re-evaluating their military strategy after the crisis in the continent. In March of 2022, Sweden and neighboring Finland were conducting exercises off Gotland when 4 Russian fighter jets intruded Swedish airspace for a brief moment. Even so, it was considered a severe incident. In the words of reporters Nicholas Rolander and Ott Umalas, quote, "A wealthy Nordic nation that had become accustomed to being far away from war zones, Sweden, along with governments across the region, is preparing for the possibility, unthinkable until recently, of a conflict with Russia." Amidst the tense atmosphere of the Cold War, a sleek and agile tank emerged as a symbol of innovation and prowess at a time when nations raced to develop cutting-edge military technology, the FV-101 Scorpion. As it roared to life, the Scorpion's lightweight aluminum armor, swift maneuverability, and potent firepower made it a formidable presence on the battlefield. From the icy terrain of Norway to the scorching deserts of the Middle East, this remarkable tank proved its worth time and time again. The Scorpion was no ordinary tank. It was designed for reconnaissance, demanding unparalleled speed and stealth to navigate treacherous landscapes and gather vital intelligence. Its low ground pressure and nimble design allowed it to traverse even the most difficult terrain, outpacing and outsmarting enemy forces. Throughout its history, the Scorpion has seen action across the globe, from the Falklands War to the Gulf War, leaving an indelible mark. But amidst all its battles and triumphs, one particular upgrade would propel it to legendary status and etch its name in the record books. In the 1960s, at the height of the Cold War, the British Army sought to create a family of lightweight, fast, and versatile vehicles known as Combat Vehicle Reconnaissance Tracked, or CVRT. Among them, the FV-101 Scorpion, developed by Alvis Vehicles Limited, emerged as a standout. It all began in 1967, when Alvis received a request for 30 prototype vehicles, which, when finished, underwent extensive field trials in Norway, Australia, Canada, and Abu Dhabi. These tests ensured the vehicle's reliability and adaptability in extreme temperatures and diverse terrains. After necessary improvements, the Scorpion was accepted for service in May 1970, with an initial order of 275 units. The quintessential British light tank, weighing a mere 8 tons, achieved its lightweight design by using a 12.7mm all-welded aluminum armor hull, providing protection against 14.5mm projectiles and 7.62mm armor-piercing rounds. A special coating applied to the hull's interior prevented rapid burning in the event of a hit, while a completely sealed hull offered nuclear, chemical, and biological protection and was equipped for semi-amphibious crossings. The Scorpion's low profile and compact design made it difficult to detect on the battlefield, while its well-sloped front plate and slightly sloped sides offered additional protection. Divided into 3 compartments, the Scorpion housed the driver at the front left, the power pack at the front right, and the fighting compartment at the rear. Notably, the driver had a single-piece hatch cover and a wide-angle day periscope, which could be replaced with a Thales passive periscope for night missions. Initially powered by a Jaguar J60 engine, the Scorpion later transitioned to a diesel Cummins BTA 5.9-liter, or a Perkins equivalent, to increase its range. The final engine choices made the Scorpion reach top speeds of 50 miles per hour on land and 3.6 miles per hour in water. The well-sloped turret featured a hand-crank mechanism for cost-saving purposes and a full 360-degree traverse. Its main armament was the Royal Ordnance Factory's 76mm L-23A1 gun, with a 6-round-a-minute firing rate and an effective range of 7,215 feet. It could fire various ammunition types, including high-explosive squash heads, smoke, and canister rounds. Complementing the main armament was a coaxial 7.62mm A43A1 machine gun and 2 multi-barreled smoke grenade dischargers on either side of the turret. Equipped with wireless radio, image intensification sights for the gunner and driver, and infrared vision, the Scorpion was well suited for modern warfare. Between 1973 and 1994, Alvis produced more than 3,000 of these CVRT vehicles, half of these for use by the British Army and the rest for 23 more armies worldwide. Later on, the Royal Air Force Regiment would also acquire Scorpions for airfield defense. The FV-101 Scorpion was first introduced into service with the British Army in May 1973, and it was initially issued to the 17th 21st Lancers, a cavalry regiment, as part of their role in reconnaissance and providing rapid support to infantry units. Throughout the tumultuous 1980s and 90s, the FV-101 Scorpion roared into action in various conflicts in which the British Army was involved. In the Falklands War of 1982, British forces found themselves fighting across the unforgiving, boggy terrain, opposing the Argentine Army's French-built Panhard AML-90 armored cars. With its low ground pressure, the Scorpion was able to slice through the landscape to provide essential reconnaissance and support. While the two forces never clashed directly, the Scorpion's presence instilled fear and respect in the enemy. On one occasion, as one Scorpion raced across the island, its three-person crew encountered a hidden danger, a landmine lying in wait for an unsuspecting victim, detonating a powerful explosion that sent a cloud of dust and debris into the air. Miraculously, the Scorpion's robust design and sturdy aluminum armor shielded the crew from the brunt of the blast. Despite the damage, the crew emerged unscathed, a true testament to the vehicle's durability. The FV-101 Scorpion also played a crucial role in supporting the British forces as part of the coalition effort to liberate Kuwait from Iraqi occupation. Among the British units committed to the conflict were 32 Scorpions of the 1st Queen's Dragoon Guards and additional vehicles in reconnaissance units. Meanwhile, the 1st Squadron of the RAF Regiment also deployed their Scorpions. In its later years, from the sweltering jungles of Belize to the cold, unforgiving Arctic, the Scorpion left a trail of success in NATO exercises and counterinsurgency roles. The three-man crews honed their skills in rigorous conversion exercises like Glory Hawk, where up to two could fit inside a Lockheed C-130 Hercules and be lifted into the air. All these participations solidified the Scorpion's reputation as a reliable and versatile combat vehicle, able to adapt to diverse operational environments. Moreover, the Scorpion was designed to have low ground pressure, similar to a foot soldier, a feature that proved invaluable during its first battle with the United Kingdom Army. Despite the British Army having retired its fleet of Scorpion tanks from frontline service in 1994, numerous nations worldwide continued to rely on this venerable light tank, and each country has its unique story and reason for keeping the Scorpion as part of its military arsenal. Major operators outside the UK and Ireland included Belgium, Spain, Bolivia, Chile, Honduras, the Philippines, Nigeria, Venezuela, Iran, Jordan, Oman, and the United Arab Emirates. But in the twilight of its operational life, a lone FV-101 Scorpion would be cast into the limelight once again. On March 26, 2002, Roy Hopkins, a retired British Army serviceman, commandeered his venerable Scorpion on English soil, and beneath its armored shell, the heart of the tank was replaced. The original Jaguar J60 petrol engine had given way to the Perkins engine's T6-3544 diesel engine. This new powerhouse endowed the Scorpion with an unprecedented surge of power and torque. And on that day, the Scorpion didn't just move, it blitzed and roared, clocking an astonishing top speed of 51.1 miles per hour. For that feat, the Scorpion became the Guinness World Record holder for the fastest production tank in history, cementing its rightful place in warfare technology history. And while the roar of the Scorpion may have faded with time, its impact and legacy linger on as a symbol of an era defined by technological advances and geopolitical struggle. Croatian company Docking has taken the engineering world by surprise by introducing one of the most sophisticated robotic and autonomous systems developed to date. And with good reason. The MV4 Scorpion is a multi-purpose, light-tracked, remote-controlled system that can be used for many purposes, tailored for military and civilian use. Initially made for clearing unexploded ordnance and anti-personnel mines, the Scorpion is fully armored from all sides to protect it from explosives and get the job done using a steel flail attachment tool. Nevertheless, the multi-purpose vehicle can also be fitted with a grip to lift and move objects, such as cars and obstacles, a dozer blade to clear roadblocks, a tiller, segmented roller, a forklift, and even an EOD arm for digging and cutting. If that was not enough, the the Scorpion can be easily transported by helicopters, cargo aircraft, containers, and car hauler trailers. For these and many other reasons, it has reached almost every corner of the world. Do not send a man to do a machine's job is the motto of Doking, an engineering powerhouse of heavy-duty robotics and autonomous systems based in the capital of Croatia, Zagreb. This international market leader company has more than 80% of the market in over 40 countries. It is present in several countries, such as the United States, the Republic of South Africa, the Republic of South Korea, and the People's Republic of China. After more than 30 years in the robotics industry, Doking has been globally recognized for bringing changes to the industrial scene with innovative approaches, earning dozens of awards internationally. Doking has committed itself to integrating its technology, innovations, and robotic systems to protect human life and property in dangerous environments, and providing its assets for military engineering, underground mining, and emergency responses. The company has produced several robotic and autonomous systems for various specific tasks. Some of them are the MVF-5 Emergency Robotic System for disaster management and the XLPS Extra Low Profile Dozer for underground mining and deep excavation. For HMA, or Humanitarian Mine Action, Doking has developed the MV2 Compact EOD Robotic System, also known as the Honey Badger, the MV10 Heavy-Duty EOD Robotic System, and MV4 Multi-Mission EOD Robotic System, better known as the MV4 Scorpion. According to Doking, the MV4, quote, is one of the world's best-renowned light category mine clearance and EOD robotic systems. Its low profile and robust structure make it resistant to all AP mines, detonations, and UXOs of similar intensity. It can also sustain AT mine explosions. The MV4 is the only mine clearance and EOD robotic system in its category that has proved its efficiency in real combat environments. Although the MV4 Scorpion was originally designed for human demining, Doking engineers took inspiration from previous designs, such as the MV1, MV2, and MV3 mine clearing systems, to create something different and more powerful. The result was a multi-purpose robotic system with additional enhancements and attachments tailored for several activities and scenarios besides mine-clearing operations. The base model of the MV4 Scorpion, without specific attachments, has a length of 3.1 meters, a width of 1.54 meters, a height of 1.49 meters, and an approximate weight of 5,025 kilograms. It's powered by a Perkins 1106 modified 6-cylinder water-cooled turbocharged diesel engine that provides over 250 horsepower and consumes between 15 and 20 liters per hour of usage. The fuel tank has a capacity of 70 liters, and hydraulic oil capacity is topped at 200 liters. The Scorpion has a transport speed of over 5 kilometers per hour and an operational speed of over 1.26 kilometers per hour. The structure of the MV4 Scorpion is protected by Hardox 450 steel plates that are between 6 and 20 millimeters thick, depending on the area. All of the tools employed by the vehicle are resistant to mine blasts. In July 2004, the Swedish EOD and Demining Center proved the MV4 Scorpion could withstand the explosion of landmines and standard 7.62mm NATO ball ammunition. The terrain is not an obstacle for the Scorpion. Thanks to its powerful engine and design, it can easily overcome rough terrain and reach unapproachable areas. It has a fording depth of 45 centimeters, a clearance depth of 30 centimeters, and a clearance width of 1.8 meters. The Scorpion can traverse slopes of 35 degrees up and down and longitudinal slopes of 20 degrees. The MV4 can also drive on transversal slopes of 45 degrees. It can employ its hydraulic arm to perform self-recovery from a trench or channel in case it gets stuck. To bolster its area of operations, Doking developed the Scorpion with ease of transportation in mind. It can be transported from one location to another without special needs or escort. By air, the Scorpion can be delivered by cargo airplanes or rotary-wing aircraft using lifting points. The Scorpion can be delivered by truck and car hauler trailer by land. Through the sea, the MV4 can be transported by container. The Scorpion features a hardened steel flail attached to several hammers at the end. Once fitted, the MV4 can perform mine clearance, soil treatment, and vegetation cleaning. Two different flail hammers provide additional protection to the vehicle. The light flail is made of high-resistant steel and used for standard terrain. Meanwhile, the second flail is made of hardox steel and is employed against difficult terrain. Both resist AT mine blasts and IED explosives of similar nature. The tiller unit is also used for mine clearance and mechanical ground preparation. It has 58 steel-teeth levers with claws that can break mines up to a depth of 25 centimeters. It can also cut down young trees or bushes in zones with abundant vegetation. Another tool in the Scorpion's arsenal is the segmented roller unit for clearing paths or specific areas. It employs 12 rollers that have a clearing width of over 2 meters. The dozer blade is used for earth moving, breaching, and mobile cover, with a pushing capacity of 4 tons. Likewise, the rear shovel has a lifting height of 2.4 meters. The EOD arm, composed of a claw, bucket, and hydraulic cutter, handles dangerous objects, digging, cutting, and deep interrogation. Its lifting capacity is 400 kilograms. Other tools in the Scorpion's arsenal are the rotational gripper for removing obstacles and the segmented roller. The Scorpion was later upgraded with a video camera system of 9 cameras that allows the operator to observe its position by picture-in-picture modes. This upgrade also allows the Scorpion to operate remotely with a controller up to 1.5 kilometers away. Docking has delivered more than 150 Scorpions fitted for the mine clearance role to multiple armies worldwide. Some include the United States, South Korea, Greece, Ireland, Sweden, Croatia, Sri Lanka, Nicaragua, and Colombia. The U.S. Army employed over 40 Scorpions under the designation M60 MV4 during its military presence in Afghanistan, saving the lives of hundreds of infantrymen from the dangers of mines placed by insurgent forces. In 2020, South Korea commenced employing the Scorpion for mine clearance operations. Docking announced it would train 11 specialists from the Army to effectively employ the vehicle for multiple operations. On October 5, 2022, Docking hosted a multinational delegation from Europe to train police officers, firemen, and professional forestry managers to properly use the MV4 to fight forest fires. During that same month, the Swiss Foundation for Mine Action announced it would supply Ukraine with MV4s to help the country clear mines in urban and rural areas affected by the conflict. In February 2023, Docking donated 8 fully equipped Scorpions to Ukraine for humanitarian demining. The company has recently presented the latest version of the robotic vehicle to the Military Diplomatic Corps of 11 countries to showcase its use for underground mining, military engineering, and nuclear, chemical, biological, and radiologic handling of hazardous material. After more than 40 years of battle-tested use, the French army is ready to let go of its aging fleet of véhicules de l'avant blindés, or VAB, and replace it with a more powerful armored personnel carrier, the Griffin VBMR. This 6x6 wheeled armored vehicle is about to become the new troop transport vehicle of the French military. Fitted with a 400-horsepower Renault engine and a 400-liter tank, the Griffin has an autonomy of over 800 kilometers and can reach speeds of more than 90 kilometers per hour. It can easily traverse the harshest terrains, such as jungles and rocky mountains. The 24.5-ton APC can swiftly deliver up to 8 soldiers in the heat of battle under cover of a hull resistant to heavy machine guns, artillery rounds, and nuclear material. While in a combat zone, the Griffin can provide cover to its troops with an arsenal of heavy machine guns to deter hostile enemy forces employing small arms, and even keep armored vehicles at bay when equipped with anti-tank guided missiles and smoke grenades to attack, relocate, and destroy enemy armor from different positions. The Véhicule de l'Avant Blindé, or VAB, simply known as Armored Forward Vehicle, has served with distinction to the French armed forces since its introduction in 1976, during the turbulent days of the Cold War against the Soviet Union. The armored personnel carrier has served France and its allies in the Western Sahara War, the Lebanese Civil War, the Bosnian War, the Gulf War, Afghanistan, and even the ongoing Russo-Ukrainian War as of 2023. The VAB developed by Renault Trucks Defense, was exported to more than 15 countries and evolved into more than 30 variants and sub-variants, producing over 5,000 armored vehicles. Besides transporting troops to battlefields or wherever they are most needed, the VAB was well suited for mechanized infantry combat, medical evacuation, anti-tank, mortar, artillery observation, reconnaissance, and electronic warfare roles. Despite its continuous upgrades and battle-tested performance, the French army started phasing out the VAB in 2019 and replaced it with the more powerful VBMR Griffin vehicle. In 2014, during a visit to the 27th Mountain Infantry Brigade Artillery of Varsailles, Jean-Yves Le Drian, the French Minister of Defense, handed the EBMR program, or Armored Multi-Roles Vehicles Project, to the CEOs of the GME, a Groupement Momentané d'Entreprises, formed by the French companies Next Air Systems, Renault Trucks Defense, and Thales. The consortium and the French Army agreed on delivering over 1,700 vehicles, beginning production in 2018 and 2019. The Griffin is a 6x6 wheeled armored vehicle developed to replace the aging VAB and function as the newest troop transport vehicle for the French military. The Griffin shares up to 70% of commonality with upcoming Jaguar ERBC wheeled armored fighting vehicles. A prototype was showcased for the first time during Eurosatory 2016 in Paris, France. Contrary to the VAB and its 30 versions, the consortium announced the Griffin would only be available in 6 variants, these being the MEPAC, Ambulance, CRBN, Engineering, Command and Artillery Post, and the ATV, or Troop Transport Vehicle, which comprises a refueling medium-range missile and sniper shooting section versions. The Griffin has a length of 20 feet, a width of 8 feet, a height of 9.8 feet, and a gross vehicle weight rating of 24.5 tons. These dimensions are designed to afford it agility and versatility in the battlefield. The Griffin has a standard vehicle arrangement with the power pack at the front, the crew in the middle, and the troop compartment at the rear. The crew of 2 comprises a driver and gunner, and up to 8 soldiers can sit in the compartment area. The exterior structure offers protection against underhull mines, artillery spray from 155mm shrapnel, 14.5mm light weapons, and improvised explosive devices. The Griffin has a 400 horsepower engine, coupled with an automatic gearbox, independent running gears, and 6-wheel drive, providing excellent tactical mobility. The Griffin also features a steering rear axle, roll-flat system, inflation pressure variation system, and state-of-the-art electronic architecture. All these innovations allow the Griffin to reach speeds of up to 90 kilometers per hour on different types of terrain. The 400-liter capacity of the tank affords the Griffin a staggering 800-kilometer range, more than enough for long-term missions. The Griffin is also prepared for anything that happens on the battlefield. It was designed with repairability in mind and is very easy to maintain. The motor propulsion unit can be removed and reinstalled in less than 4 hours. In order to protect the troops inside, the Griffin features a remote weapon station that can be armed with a 40mm grenade launcher or a 7.62 or 12.7mm machine gun, which can include launchers for smoke grenades. When the mission requires stronger, more specific firepower, 2 Acheron MP anti-tank guided missiles can be fitted. Depending on the combat scenario, the Griffin crew can decide which armament fits better. If the objective is to deliver men in a combat zone with enemy forces using small arms, a machine gun can be more than enough to provide them cover while they reach the hot zone. On the other hand, if faced with enemy armored vehicles in the combat zone, the anti-tank guided missiles would come in handy to keep the enemy at bay and deploy smoke grenades to conceal the movements of the Griffin while it moves across the battlefield to attack from different zones. To this end, the Griffin's turret has a day and night sighting system to bolster accuracy and enemy detection over the battlefield. The turret also features a Metrovib Slate acoustic sniper localization system. Other features of the Griffin include a command, control, and networking system, laser and radar warning protection system, missile detection, and the standard NBC, or nuclear, biological, and chemical protection, with overpressure and air conditioning, allowing the personnel inside more than adequate shielding from whatever the enemy throws their way. The first roadworthy Griffin multi-role combat vehicle prototypes began performance trials in August 2019, with more scheduled to be delivered by 2020 for additional tests. In September 2020, the French Army Technical Section performed the first boarding tests of the Griffin VBMR aboard the Navy's Mistral amphibious assault ship. the Griffin armored vehicle boarded the Mistral through the ship's side door to verify its interoperability with an amphibious vessel moored to a harbor without a ro-ro or roll-on-roll capability. According to Nathan Gain from Naval News, this successful trial complemented other amphibious tests conducted months earlier, including testing Griffin's boarding capabilities with the French EDAR-R rapid amphibious craft and the CTM standard amphibious landing craft. The Scorpion program is an ambitious, large-scale modernization project aiming to update existing vehicles with new capabilities and procure new ones. During the success of these tests, which have proven the amphibious capability of the Griffin, there's still a long way to go, as the French military is still in the transition phase of an all-Scorpion model, merging a dual competence, that of an onboard battle group and a Scorpionized battle group for amphibious operations. France seeks to bring the entire military into an age of collaborative and synchronized combat, which explains why they seek to modernize their combat vehicles with robust sensors, drone integration, and new levels of communication between troops of different branches. On December 21, 2021, the new French combat vehicle developed by Engin Blindé Multirolles for the Scorpion program achieved a new milestone, delivering the 119th and last troop carrier scheduled for 2021. The Groupement Momentané d'Entreprise, comprised of Nexter, Arquus, and Thales, took to the media to mention that they had met their delivery target for 2021. In early 2020, another 128 combat vehicles were submitted for verification, leading to a total of 339 delivered to the French armed forces. The latest delivery by the GME also confirms that all troop transport variants of the Griffin are now fully qualified, including the 81mm mortar MO81, refueling RAV, engineer GEN, medium-range missile MMP, and the command post vehicle EPC versions. Delivery of more Griffin vehicles and tests will continue throughout 2023 to continue improving the capabilities of France's latest armored vehicle. It is expected the last Griffins will be delivered by 2025, according to the schedule set by the military and the GME. The sound of gunfire echoed through the desert wasteland as the Swedish combat unit advanced deeper into enemy territory on a perilous reconnaissance mission. But in the middle of the night, just as the infantrymen took a respite, they were startled by the sound of explosions. The enemy had found them. The Swedish soldiers were outnumbered and outgunned, and they quickly found themselves surrounded by Afghani fighters. The commander desperately radioed for backup, but he knew it would take some time before help arrived. They had to hold out until then. He then ordered his men to take cover behind the dilapidated buildings of an abandoned village and return fire. The enemy unleashed RPGs and heavy machine gun fire, which soon enveloped the soldiers from every direction. To make matters worse, they couldn't determine where the enemy was positioned. Then, in their darkest hour, a friendly CV-90 fighting vehicle arrived. The sound of its engine thundered over the gunfire, and the soldiers felt a sense of relief wash over them. With its groundbreaking array of environmental sensors, the fighting vehicle's operators immediately pinpointed the enemy's location and targeted them with their 30mm cannon. The Swedish soldiers could hear the whistling sound of the rounds as they flew past them and shredded enemy positions, and the distraction allowed them to launch a decisive counterattack. The formidable CV-90 had averted a possibly lethal ambush, one of many deeds that have earned it the reputation of being the best infantry fighting vehicle in the world. The CV-90 family of vehicles has become one of the most trusted infantry allies for Swedish and NATO fighters across the world. Its achievements and remarkable performance can be traced back to its unique design and the fascinating Swedish outlook regarding weapon and vehicle design. Since the end of World War II, Sweden's weapon manufacturing industry has wholly embraced a unique design philosophy based on defensive features like survivability, adaptability, and modularity, even at the cost of raw firepower or affordability. In the 1950s, such philosophy became evident when Swedish engineers realized that most hits occurred when enemy fire struck the tank's turret. Thus, they designed the Stridsvagn 103, the only modern battle tank in the world with no turret and a fixed main gun configuration. The idea appeared ridiculous at first glance, especially when other nations were building larger, more prominent turrets capable of carrying immense firepower. But testing showed the peculiar Swedish tank could outperform many conventional armored vehicles, while having the massive benefit of an extremely low profile that kept the crew safe from prying eyes. Although considerably more conventional in design, the CV-90 was designed with the same approach in mind, with their creators focusing on protecting the crew by building a vehicle with a low profile, high mobility, and maximum crew safety. BAE Systems Hägglunds, the manufacturer of the CV-90 family of vehicles, has noted repeatedly that under their philosophy, protection is not the same as survivability. While their infantry fighting vehicles, or IFVs, are equipped with a wide array of protection assets such as thick armor plates and radiation and biological toxicity filters, they designed the CV-90 to have superb survivability as the first priority. According to their unique perspective, heavy protection is of little use if you can't see the enemy or respond swiftly to what it does, which translated into the tank's high mobility, responsiveness, and speed while wielding maximum environmental awareness. During the Cold War in the 1980s, the Swedish Army faced a critical need for highly mobile vehicles that could provide air defense and anti-tank capabilities while ensuring high survivability and protection for the infantry. The stakes were incredibly high, as any delay or misstep in developing these vehicles could leave the Swedish military vulnerable to potential threats from the ever-expanding Soviet Union. To address the menace, in 1985, a project group made up of representatives from the Swedish Armed Forces, the FMV, and the Swedish arms industry stepped up to the challenge and submitted the design for the Stridsfordon 90. The combat vehicle was based on a previously scrapped Air Force concept, and it aimed to meet all the Army's needs. However, the project faced numerous obstacles, including technological limitations and budget constraints. Even so, the project group managed to surpass the numerous technical and logistical obstacles, and in 1986, they began constructing the STRF 9040 and STRF 9025 prototypes. However, the financial pressures forced the team to abandon the 9025 prototypes shortly before delivery in 1988. The 5 STRF 9040 prototypes were tested extensively between 1988 and 1991, and the project group ordered prototypes for specialized variants, including forward observation, command and control, and armored recovery vehicles. Finally, in 1994, the first deliveries of the Stridsfordon 90 began, marking a significant milestone in the history of the Swedish Army. Since then, the CV-90 has undergone 4 comprehensive mark shifts that have taken the vehicle from the CV-90 Mark 0 to the CV-90 Mark 4. The significant updates have been possible thanks to the vehicle's formidable performance, which has led its developers to continue to invest in the project. Moreover, the CV-90 Mark 0 won a competition against contemporaries, such as the American M2 Bradley, British F5 V10 Warrior, and Austro-Spanish Ascod, immediately earning international attention. The subsequent overhauls have made the vehicle faster, more maneuverable, and more lethal, thanks to a new Scania 1,000-horsepower engine, an upgraded X300 heavy-duty transmission, a 35 50mm Bushmaster 3 cannon, and a wholly modernized weapon control system. The CV-90 fighting vehicle has a rich combat history, having served in numerous conflicts around the world, and one of its most notable deployments was during the Balkan Wars in the 1990s. The Swedish Army deployed their CV-90s to Bosnia in 1996 as part of the United Nations peacekeeping mission. The vehicles proved highly effective in the challenging terrain, earning praise from their operators and other military officials. In 2006, the Norwegian Army deployed its CV-90s to Afghanistan as part of the International Security Assistance Force. The vehicles performed exceptionally well in the harsh environment, providing troops with essential fire support and mobility. Brigadier General Robert Mood, former Norwegian Army chief, described the vehicle's performance as, quote, "The CV-90 has been the backbone of our armored units in Afghanistan, and it has performed well." The CV-90 has also been involved in various training exercises worldwide. In 2015, the Finnish Army participated in a multinational exercise in Norway, during which they deployed their CV-90s. The vehicle's incredible set of features heavily impressed the international military community. As Finnish Army officer Captain Tommy Lindholm put it, quote, "The vehicle's capabilities have been put to the test in demanding terrain and extreme weather conditions, and it has passed with flying colors." The CV-90's advanced technology and versatility have made it highly sought after by military forces worldwide, which has led BAE Systems Hägglunds to significantly expand their production program for the IFV. With such high demand, the Swedish manufacturer has committed to continuing the evolution of the combat platform, as the potential it showcases is almost unparalleled. Even when compared to other top-of-the-line IFVs, such as the American Bradley, Russian BMP-3, German Puma, and Israeli Nemer, the CV-90's remarkable situational awareness and survivability have earned the preference of many military factions and strategists, who often rate the vehicle as the best IFV on the planet. Ultimately, the CV-90 has proven itself as a formidable fighting vehicle, earning high praise from military officials and operators alike. Its advanced technology, exceptional mobility, and firepower have made it a crucial asset in several conflicts worldwide. During the 2018 Eurosatory exhibition in Paris, Rheinmetall presented a groundbreaking technological innovation that may change the way that infantry engages the enemy on the battlefield. It was the Mission Master Cargo Unmanned Ground Vehicle. Besides helping alleviate a soldier's carry load, the Mission Master UGV can effectively detect and engage the enemy with state-of-the-art artificial intelligence and the latest weaponry against hostile troops and armored vehicles. Even more impressive, the Mission Master can scan the environment and provide immediate feedback to other units, and it can make its way through rocky terrain, mud, sand, and even cross rivers with ease thanks to its hybrid nature, as it can also be controlled by an operator when the fighting turns more difficult. Having a Mission Master UGV in the battlefront will help elite operators analyze the surroundings, take their positions, and fire explosive projectiles when the enemy least expects it. That is what the future of combat looks like. The Mission Master Unmanned Ground Vehicle, or UGV, was built with customization in mind, and it can be configured for different combat scenarios or operations. In addition, it features several modular, easy-to-install payloads, and can be customized for medical evacuation, fire suppression, transport, surveillance, communication relay, and other roles. During a press conference at the 2018 Eurosatory exhibition in France, Stephanie Orley, President and CEO of Rheinmetall Canada, said, quote, "Supporting soldiers in the field has always been the guiding force of our company. Because we are constantly searching for new ways to support missions, we recognize the need for a new type of asset that would free up troops to focus on more important tasks. With the all-new Mission Master Cargo, soldiers can leverage artificial intelligence and robotic muscles for the dull, dirty, and dangerous parts of the mission, and most importantly, safely accomplish their tasks on the field." Orley also highlighted the autonomous and semi-autonomous capabilities of the Mission Master Cargo, pointing out that its carry capabilities and other specific functions can help soldiers focus on the most critical aspects of an active operation. Besides, each Mission Master vehicle is fully compatible with Rheinmetall's soldier system and the command and control software, allowing troops to link up with the vehicle and control it freely. The Mission Master is a low-profile unmanned ground vehicle that is compact, stealthy, and highly mobile. Plus, it has a low-signature motor that combines stealth and agility for discrete operations. With a length of 2.95 meters and a base weight of about 750 kilograms, the all-terrain Mission Master can follow troops anywhere they are. With this in mind, the vehicle can be used as a battle companion that accompanies soldiers anywhere on the battlefield to get close and personal with the enemy without being seen or heard. To traverse all sorts of terrain, including rocky landscapes, muddy forests, or wet riverbeds, the Mission Master was developed with astonishing amphibious capabilities and total mobility within extreme conditions. It can travel some 750 kilometers before refueling, and an integrated battery can extend its range even further, ensuring more hours of silent operations and an average speed of up to 40 kilometers per hour. The vehicle also features a fully amphibious 8x8 chassis that can be fitted with tracks if the terrain is too rough. And for ground operations, the unmanned vehicle can transport payloads of up to 1,000 kilograms. Nevertheless, the vehicle's payload carrying capacity is limited to only 300 kilograms for amphibious operations. Still, the UGV can handle the weapon systems and sensors of a platoon or a company across the unforgiving terrain, allowing the troops to carry heavier caliber weapons and optics that they would typically leave at the base to ease their loads. Ultimately, the addition of the vehicle results in an increase in firepower and range for the soldiers on the field. The Mission Master vehicle and all of its modular payloads are powered by the Rheinmetall Path Autonomy Kit, or A-Kit, which enables the UGV to operate in unmanned mode and helps the soldiers be focused and present. Additionally, the A-Kit allows several connectivity options, allowing troops to operate the vehicle with a tablet, smartwatch, single-hand controller, or Rheinmetall soldier system. Some of the Path system features include basic options such as Follow Me, Convoy, Autonomous, and other predetermined modes. Each has unique configuration layers that guarantee that the Mission Master will carry on with the mission with success and efficiency. Also, the Path system is highly flexible and customizable thanks to its open architecture, allowing first-hand innovations that will improve as artificial intelligence evolves. The Mission Master UGV is highly customizable and can be adapted for different operations. For an aggressive loadout, the vehicle can be armed with two 20-kilogram F-2220 composite 7-tube rocket launchers developed by Thales Company. Each launcher can fire 70mm unguided rockets in single or ripple mode using a removable dual-purpose F-2125 detent mechanism. The launchers can also fire aerial rockets and F-2275 laser-guided rockets, while other armament includes 50-caliber machine guns, 40mm grenade launchers, and 50mm weapons. The Mission Master is also the first UGV to incorporate a tube launcher system with Warmate micro-combat UAVs. The system allows it to identify and track targets hidden on the battlefield prior to conducting an attack in order to minimize collateral damage. Meanwhile, the reconnaissance variant of the Mission Master features unique assets that enhance its performance, such as intelligence-gathering technology and bidirectional communication systems. Some include a surveillance radar, laser designator, laser rangefinder, and a 360-degree full-ring camera. With the Wolfpack concept, multiple Mission Masters can work together as a team to perform different roles during a single operation and enhance the overall performance of the Wolfpack. And for easier and faster transportation, the vehicles can be fitted with a 3.5-meter tall expandable mast so that they can be carried by Chinooks and CH-53s. Rheinmetall unveiled a new feature of its Mission Master XT vehicle during the Eurosatory exhibition that took place in Paris in June 2022. Developed in partnership with U-Vision, Rheinmetall introduced the new Fire Support Module, which is armed with the Hero 120 loitering munition system and provides the shortest and most effective sensor-to-shooter effector. According to the company's statement, the Hero 120 system is a smart, high-precision loitering munition system with a unique aerodynamic structure. It is capable of conducting accurate strikes and has a wide variety of multi-purpose warheads that are highly effective at all ranges. They can also engage and destroy all types of soft and hard targets with relative ease, ensuring minimal collateral damage. Following the human-in-the-loop principle, the Hero 120 can calculate with almost perfect precision the target and area of attack to minimize unexpected damage. According to the company, the constant recording of the operation on the ground provides proof of compliance with strict rules of engagement. The Hero 120 also maintains excellent accuracy during night operations, thanks to the electro-optic and infrared homing device that enables non-line of sight, or NLOS engagement, under most weather conditions. This device can track both static and moving targets. In addition, the system has a small footprint and low acoustic and minimal thermal signature, making it ideal for any warfighting force. The The Hero 120 allows the Mission Master XT vehicle to independently locate, track, and eliminate any armored target, no matter the range, weather conditions, or the presence of hostile jammers that can disrupt GPS and communication signals. This new fire support module with the Hero 120 system is expected to significantly bolster the already impressive capabilities of the Mission Master XT. A 6x6 vehicle with a mounted howitzer cannon is unloaded from a C-130 onto the battlefield. An uncommon sight in the military world, the Nexter Caesar's self-propelled howitzer brings its 155mm cannon power to the French military. Its crew of 5 swiftly take their positions, ready for action. With a deafening blast, the cannon fires, echoing across the rugged terrain. A target almost 40 kilometers away is obliterated, demonstrating Caesar's unbridled firepower. As quickly as it arrived, it moves into a better firing position, traveling 100 kilometers per hour. It easily navigates the battlefield, showing its perfect combination of mobility, survivability, and firepower. Deployed to Ukraine as part of a French aid package, Caesar is put right in the spotlight. This test is not just about firepower, it's about proving its mettle on a global stage. As it plays a pivotal role in combating the Russian invasion, the eyes of militaries worldwide are keenly watching. The camion équipé d'un système d'artillerie, dubbed Caesar, is a French truck equipped with a 155mm self-propelled gun howitzer. It was developed in the 1990s as a technology demonstrator for the French companies Giat Industries and Lohr Industries. The Caesar artillery system was officially unveiled to the public in 1994, and a small pre-production batch was delivered to the French military for testing in 1998 and 99 before being officially adopted in the mid-2000s. Caesar is the successor to previous French self-moving artillery guns fitted with an auxiliary power unit, evolving directly from the F-3 self-propelled howitzer based on the AMX-13 light tank chassis. French military doctrine from the 1990s called for the development of an artillery system that could support the rapid deployment of forces to provide them with heavy firepower as they pushed toward enemy territory. This artillery system had to fulfill the demands of new combat tactics, and the Caesar delivered, replacing the TRF-1 155mm howitzers by 2007. At the time of its introduction, the concept of a truck-mounted artillery system was uncommon, leading to quick exports to militaries worldwide. Although some analysts and engineers doubted the concept of mounting a powerful and heavy howitzer on a military chassis, the Caesar proved its worth. It led to a new generation of truck-mounted artillery systems. The Caesar has a weight of 18.5 tons, a length of 10 meters with the gun forward, a width of 2.5 meters, and a height of 3.26 meters. It's powered by a Renault DCL6 diesel engine, providing over 240 horsepower, allowing the artillery system to reach a top road speed of over 100 kilometers per hour with an estimated range of 600 kilometers. The Renault Sherpa 5 6x6 truck chassis gives the Caesar excellent off-road capabilities to traverse uneven terrain and position itself anywhere it's needed. Furthermore, due to its size and weight, Caesar can be airlifted by cargo aircraft such as the C-130 Hercules, C-17 Globemaster, or the Airbus A400M for quick deployment. Following the success of the Caesar during its first years, Nexter decided to develop an upgraded artillery system in the form of the Caesar 8x8. The main difference resides in the 8x8 chassis, increasing mobility and cargo capacity. Like its predecessor, it requires a crew of 5 to operate. The 155mm howitzer can maintain a firing rate of 6 to 8 rounds a minute and be ready for action in over 1 minute. In addition, the 8x8 Caesar features a fast-hit computerized fire management system and a ROB-4 muzzle velocity radar system. Loading is still semi-automatic, but features an automatic hydraulic laying system. The 155mm gun has a range of more than 40 kilometers. It can be increased depending on the type of ammunition, such as rocket-assisted HE-frag shells, smoke and illumination shells, anti-tank or fragmentation bomblets, and even Spacito or bonus precision-guided anti-tank munitions. Caesar is also capable of MRSI, or multiple-round simultaneous impact firing. The howitzer can launch several projectiles in different trajectories, and they all can hit their intended targets simultaneously. The fire control system is also integrated with the Thales Land and Joint Systems Atlas Artillery C4I. It comprises onboard terminals for communications and real-time firing sequence management. In combat scenarios, a Caesar battery comprises 8 Caesar howitzers. It can fire more than 1 ton of shells in little more than a minute. In addition, Caesar also includes the SAGM Sigma 30 navigation system and GPS to ensure optimal topographical analysis. An optional armor kit offers Level 2 Stanag 4569 ballistic protection and artillery burst protection from 155mm shells at 5 meters. With these features in mind, Caesar combines low weight, tactical mobility, higher survivability, and stealth, thanks to its cross-terrain capability that enhances its firepower. The self-propelled howitzer has been deployed by French forces in Mali, Lebanon, Iraq, and Afghanistan. Over 300 Caesars have been developed to date, and more are to come in the following years. In February 2022, President Vladimir Putin gave the Russian army the green light to launch what they called a special military operation, the invasion of Ukraine. After months of amassing troops and supplies, the Russians poured over eastern Ukraine to capture Kyiv. 2 months later, in April, French President Emmanuel Macron told the regional newspaper West France that the French military was preparing an aid package for the Ukrainian armed forces that would include howitzers and artillery. He said, quote, "We're delivering significant equipment from Milan to Caesar. I think we have to continue on this route, always with the red line that we will not become parties to the conflict." French Defense Minister Florence Parly later confirmed on Twitter that several Caesar artillery cannons and shells had been safely delivered to Ukraine. Currently, Caesars remain operational in Ukraine, supporting infantry units fending off Russian armored vehicles and columns, and eliminating large concentrations of enemy troops and artillery emplacements. The vehicle's success in Eastern Europe paved the way for a record year for Caesar orders. In late May 2022, Nexter announced it had signed a deal with the Colombian military for the delivery of 12 Caesar howitzers to modernize the country's field artillery capabilities. Military sources from Bogotá informed Defense News that the first batch of 4 Caesars was approved with an estimated cost of $35 million, but no information was provided regarding the estimated deliveries. As the Ukrainian Caesars continued proving their worth in the war zones of Ukraine, Belgium's and France's defense ministers, Ludwina Dodonde and Florence Parly, signed a contract for the delivery of Nexter's Caesar 6x6 howitzers to the Belgian armed forces. According to a press release, Brussels invested over 62 million euros in the acquisition of this long-range precision mobile artillery platform and expects to receive all its Caesars by 2027. Furthermore, other Eastern European countries have also adopted the effective and highly mobile French artillery system. The Czech Republic ordered 10 Caesar 8x8s to complete the 52 systems ordered since 2021 during the Russian military buildup in Ukraine. More recently, the French and Lithuanian defense ministers signed a technical arrangement for cooperation in the artillery field. This included an order for 18 Caesar 6x6 Mark IIs for the Lithuanian military. As the conflict continues between Russia and Ukraine, more NATO partners will probably order Caesar systems in the upcoming months to provide their militaries with a powerful yet mobile artillery platform capable of eliminating any obstacle on the battlefield. As the dawn of the Korean War enveloped the rugged terrain, a squadron of Centurion Mark III tanks advanced into a strategic position. These beasts, the latest in British armored warfare, bristled with anticipation. Suddenly, the silence was shattered by the thunder of enemy tanks. The Centurions responded with rapid precision. Their 20-pounder guns, boasting a high muzzle velocity, unleashed a barrage of armor-piercing rounds. Explosions lit the horizon as enemy tanks recoiled under the Centurions' mighty firepower. Amidst the chaos, the Centurions' armor, up to 152mm thick at the front, proved its worth. Enemy shells ricocheted off, unable to penetrate the well-angled frontal defense. Inside, the crew of 5 operated the tanks with clockwork efficiency, coordinating every move and shot. The Centurions, weighing nearly 50 tons each, maneuvered with unexpected agility. Their Rolls-Royce Meteor engines, echoing the power of the Spitfire's Merlin engine, propelled them through the rugged landscape at speeds up to 21 miles per hour. They climbed hills and traversed valleys, demonstrating their superior handling and stability in rough terrain. As the Centurions pushed forward, their coaxial 7.62mm machine guns rattled, providing cover for the infantry. They moved through mud and over frozen ground, adaptable and relentless. Regrouped under the fading Korean skies, their journey was far from over. These machines were destined for battlefields across the globe. Their advanced design and proven combat effectiveness set them on a course to outpace their contemporaries, the American M45 Patton and the Soviet T-55. After developing the first tanks during World War I, the British struggled to come up with innovative and functional designs after the global conflict. Cruiser tanks, such as the iconic Crusader, were meant to be fast and fit the role of traditional cavalry. Still, they lacked powerful armament and heavy armor to destroy or resist attacks from the German panzers of World War II. Although the army eventually created designs such as the imposing Churchill, it was slow to exploit breakthroughs on the battlefield. In addition, most British tanks were unreliable, and their cannons could only fire armor-piercing rounds. The lack of high-explosive rounds meant the Britons could not engage infantry or anti-tank guns, only enemy tanks. This left the British tanks behind the innovative panzers, such as the Panther, Tiger I, and King Tiger, which could swiftly take over the battlefield with their thicker armor and devastating cannons. In late 1943, the British War Office realized it could no longer keep developing tanks outmatched by its counterparts and decided to pursue something new. With this in mind, the War Office issued Requirement A41 to develop a new heavy cruiser tank. Thus, under Sir Claude Gibb, the Directorate of Tank Design was asked to produce the new vehicle, considering the German designs taking over Europe. Furthermore, the War Office also contemplated the threat posed by the German 88mm gun to develop the vehicle with thicker armor to increase its survivability. A series of mediocre designs followed and progressed slowly until the prototype reached the desired specifications. After rethinking their tank gun design, the British War Office established that the vehicle could not exceed a weight of 40 tons, the limit of Mark I and Mark II transport trailers. To facilitate logistics, the desired A41 tank could also not exceed a width of 3.25 meters by the British railway loading gauge. Speed was unimportant, as the emphasis was put on firepower to overcome the lethality of the German tanks. The hull was redesigned numerous times until they added sloped armor and side armor plates. By October 1943, the 40-ton weight limit was removed, and the prototype reached a 45-ton weight due to the heavier armor and wider turret. The War Office concluded the potential of the new design could not be limited by logistics, and allowed the Tank Design Directorate to design it freely. In May 1944, 1 month before the decisive Normandy landings of June 6th, the prototype was delivered for evaluation. Soon, over 20 models with different armaments were ordered. From 17-pounders to 20mm Pulsar guns, all were tested to develop the best combination, performance, and firepower. The result was a 45-ton tank that featured sloped armor like the German Panther and the Soviet T-34 tank. It was powered by a Meteor engine, based on the powerful Merlin engine employed by the Spitfire aircraft. It was armed with a 76 2mm gun and could achieve a top speed of around 21 miles per hour. It was dubbed the Centurion Mark I, and it was the beginning of one of the first main battle tanks ever developed. The Centurion was designated as a universal tank that could combine the functions of a cruiser and an infantry support tank, leading to one of the first main battle tanks to enter production, displacing the notion of light, medium, and heavy tanks. The tank entered production in January 1945, but arrived too late to see action during World War II. By the time the Third Reich surrendered in May, only 6 Centurions had been shipped to Belgium for combat evaluations. As soon as the Centurion Mark I was delivered, the Army began developing the Mark II variant, featuring an improved hull, a fully cast turret, a coaxial Besa machine gun, and a gunner's periscope. Similarly, the Mark III featured a QF 20-pounder or 84mm gun, a shorter hull, a 51mm mortar, and an overall weight of 49 tons. It entered production in 1948 and would see combat for the first time during the Korean War. The Centurion arrived in Asia in November 1950 with the Army's 8th King's Royal Irish Hussars. Stationed in Busan, each squadron was equipped with Mark III variants, amounting to 64 tanks. The Centurion's baptism of fire was in the outskirts of Seoul, where one Mark III triumphed against a North Korean Cromwell tank, with the Hussars enduring the harsh conditions of winter warfare. To prevent their steel tracks from freezing to the ground, the Centurions rested upon beds of straw to stay battle-ready. The engines had to be turned on every half hour, and the gears engaged individually to ensure the tanks did not succumb to Mother Nature. The Centurions and their crews rose to prominence at the Battle of the Imjin River, where they protected the retreat of the 29th Brigade. 5 tanks were lost in the ruthless fight, but were later salvaged and restored. The 5th Royal Inniskilling Dragoon Guards also showcased their Centurions' prowess in repelling Chinese attacks during the Second Battle of the Hook in 1952. Similarly, the 1st Royal Tank Regiment effectively engaged the Chinese during the Third Battle of the Hook and the Battle of the Samechon River in 1953, before the United Nations withdrew from Korea after the agreement between North and South Korea. In tribute to the 8th Hussars, American General John Iron Mike O'Daniel praised the British mastery of tank warfare, declaring that tank country was anywhere the Centurions went, even atop mountains. Following the end of the Korean War, British Centurions were deployed to Western Europe as part of the NATO forces, ready to engage the Soviet Union if an invasion ever came from Germany. In 1956, Centurions were deployed as part of the British, French, and Israeli forces prepared to regain control of the Suez Canal. The tanks were deployed in Port Said's inner harbor via ship. The tanks from the 6th Royal Tank Regiment made their way through Egyptian lines, guns blazing, to link up with French paratroopers and destroy Soviet-made Su-100 tank destroyers. By the time the Vietnam War began, the British had already introduced the Mark IV and Mark V variants, providing extra armor and bolstering overall performance. Australian Centurion tanks of C Squadron 1st Armoured Regiment were deployed to reinforce fire bases Coral and Balmoral in May 1968. Their swift arrival aided in the Battle of Coral Balmoral, a 6-week engagement that resulted in the elimination of approximately 267 enemy soldiers from the 141st and 165th North Vietnamese Army regiments. The Australian forces managed to capture 11 prisoners, along with numerous enemy weapons, including 36 crew-served weapons and 112 small arms. Following the battle, the deployment of Centurion tanks intensified. Centurion crews quickly adapted to the jungle conditions, removing armored side skirts to prevent vegetation and mud buildup. Each tank carried a load of 62 rounds of 20-pounder shells and ample machine gun ammunition. By September 1968, C Squadron reached its full strength, complemented by the addition of a 3rd Centurion troop. Over the next years, various squadrons of the 1st Armored Regiment took turns in South Vietnam, expanding the Centurion's presence. Though initially only 26 tanks were dispatched, after 3.5 years of combat, 58 Centurions served, with 42 sustaining battle damage, 6 of them beyond repair. In the aftermath of the Vietnam War, the Centurion was exported to more countries, entering service in the militaries of more than 12 nations, including South Africa, Israel, India, Austria, Sweden, and others. It was heavily used during the Indo-Pakistani Wars and the Six-Day War. Over 4,400 were built between 1946 and 1962. Despite their effectiveness, the Britons phased out the Centurions in the late 1960s with the introduction of the 60-ton Chieftain. Although most of the tank's combat experience came from non-British armies, it is still regarded fondly by British military historians due to its innovations during the aftermath of World War II. Although the tank had some close calls with its Cold War-era counterparts, the American M48 Patton and the Soviet T-55, it excelled among them due to its adaptability, which kept it in service longer.